Right, and here's another homogeneous differential equation. 2 degrees, both x's, 2 degrees, 1x, 1y, 1x, 1y for a total of 2 and 2 y's. Okay, the way to do this thing is to start off by just rearranging it, so we end up with dy by dx equals xy minus y squared over x squared plus xy. Okay, so we write it in the form we've just got dy by dx equals a whole bunch of terms each with a total degree of 2. So when we make a substitution, that'll all cancel out nicely, so we're going to let y equal vx. The left-hand side by the formula, which is just from the product rule, becomes v plus x dv by dx. And on this side we're going to have x times vx minus v squared x squared over x squared plus x times vx as we make the substitution. And the good thing again is that we can cancel out an x squared from every term. So we're left with on the top line v minus v squared, and on the bottom line 1 plus v. Bring this v across to the other side, so we get x dv by dx equals v minus v squared on 1 plus v minus v. Let's give a common denominator here, so it's v minus v squared on 1 plus v minus 1 plus v times v on 1 plus v. So what have we got? We've got v minus v, so it disappears. Negative v squared minus another v squared is minus 2v squared on 1 plus v. We now need to separate the variables, so we're going to put all of the v's on the side that has the dv on the top. So bringing the v's over this side, we end up with 1 plus v on minus 2v squared, and bringing the x's over the other side, 1 over x dx. It's dv there as well, isn't it? Okay, so we're now at the stage where we can have a crack at integrating both sides. This one you want to split up into two things, so you're going to end up with minus 1 over 2v squared minus 1 over 2v, or you could take the half out the front, or whatever you want. It's integral of all that lot. dv is integral of 1 over x dx. Let's just take these 2's over this side so I don't have to worry about them. So on this side when we integrate, that's the same as negative 1 over v to the minus 2. So when we integrate that, we're just going to end up with v to the minus 1, or 1 over v. And this thing's going to go to natural log of v. And I've put the 2 over this side, so I better not forget it. So 2 log x dx. Okay, so how am I going to deal with this? Probably the easiest way to deal with this is to put all the logs on one side. Oh, what's doing me with dx? Plus c. It's a bit better, isn't it? So let's put all of the logs on one side and all of the non-logs on the other side. So I end up with 1 over v plus c equals 2 log x plus log v. And from here it's just really a matter of tidying things up. I know I changed the plus to a plus where I swapped sides, but c is just a constant, so minus the constant is the same as plus a different constant, so it just looks tidier. It doesn't really matter. So what have I got? I've got 1 over v plus some constant equals log of vx squared. Just bring those together, so I'm only using one log. And I just need to make remake the substitution. So instead of v, I'm going to use y over x. So 1 over v will be x over y plus a constant equals the natural log of v is y over x. So it's going to get the x going to go with one of those x's. So just end up with yx, and that's probably as tidy a place as you can make that happen. Okay, so it's just a bit of algebra really. So the first thing was to make sure you wrote it in the form where the total degrees are going to help. When you made the substitution, you could cancel out, and from there on it's the integration, it's the separation of variables, and a little bit of algebra just to try and make it look reasonably presentable.